Station 6, kinematics equations. In this particular problem, we have an object that accelerates from rest to a speed of 24 meters per second over a distance of 56 meters. What acceleration did it experience? No time mentioned, so I'm going to use the third kinematics equation, which is this one. V squared is equal to V0 squared plus 2a delta x. The problem says right here, what acceleration? So I know that I need to solve this equation for a. I'm going to subtract v0 squared from both sides to get v squared minus v0 squared is equal to 2a delta x. Then I'm going to divide both sides by 2 delta x. And my expression becomes a is equal to v squared minus v0 squared divided by 2 delta x. Since we started from rest, my v0 is going to be 0. My v at the end is 24 meters per second, and my delta x is 56 meters. Plugging in the numbers, this becomes 24 squared minus 0 squared divided by 2 times 56. This works out to be 5.14 meters per second squared. The marble is projected vertically upward by a spring gun and reaches the maximum height of 9.8 meters. What is the initial speed of the marble? How long did it take the marble to reach maximum height? This problem is very similar to the Stomp Rocket Lab, and we need to take advantage that at maximum height for any object thrown vertically upward, v is equal to 0. We're first going to solve for the initial speed of the marble by using the third kinematics equation. It says v squared is equal to v0 squared plus 2a delta x. This is equal to 0. I can rearrange my equation by subtracting 2a delta x from both sides. My expression becomes v0 squared is equal to negative 2a delta x. Getting rid of the square, I take the square root, and that becomes v0 is equal to the square root of negative 2a delta x. Reading my problem, my delta x is 9.8 meters, and my acceleration is negative 9.8 meters per second squared. I can plug in my values into my square root. It's negative 2 times negative 9.8. This way I don't have an error when I solve for the square root of a negative number. And this works out to be 13.8 meters per second. In the second problem, what I'm going to do is I'm going to, how long did it take to reach maximum height? So I'm going to use the first kinematics equation. V equals V0 plus AT. I know that at maximum height, this is 0. This expression simply becomes, I can subtract V0 from both sides, and so I get negative V0 is equal to A times T. Solving for T, T is equal to negative V0 divided by A. Recall that A is negative 9.8, so this becomes 13.8 negative divided by negative 9.8 gives me a time equal to 1.4 seconds. Station 6, problem number 9. An arrow is shot vertically up by a bow and after 8 seconds returns to the ground level. What is the initial velocity of the arrow and how high did it go? This problem is very similar to what you did in the Stomp Rocket Lab. You need to take advantage of the idea that v is equal to negative v0. Using the first kinematics equation, this becomes negative v0 is equal to v0 plus at. Solving for v0, this becomes negative 2v0 after subtracting v0s on both sides is equal to at. Solving for v0, it becomes at divided by negative 2. Plugging in our numbers, we get 9.8, which is negative, multiplied by 8 and divided by negative 2 will give us an initial velocity of 39.2 meters per second. In the second part of the problem, we want to calculate how high did it go. So for this, I'm also going to use the third kinematics equation would be the easiest one to use. V squared is equal to V0 squared plus 2a delta x. Keep in mind, you could use the second kinematics equation and solve it for delta x. Might be a little bit more calculation involved there. Here I can simply set this equal to 0. Rearranging my equation, I get the expression negative V0 squared is equal to 2a delta x, and that delta x is equal to negative V0 squared divided by 2a. I can now plug in my numbers of 39.2 squared, that'll be negative, divided by 2 times negative 9.8. Doing this calculation, I get the final answer of 78.4 meters. Station 6, multiple choice question. An archer practicing with an arrow bow shoots an arrow straight up 2 times. The first time, the initial speed is v0, and the second time, he increases the initial speed to 4 times v0. How would you compare the maximum height in the second trial to that of the first trial? Well, first thing I need to notice is that no times are given for how long the arrow is in the air, so I'm going to use the third kinematics equation to figure this out, which is v squared is equal to v0 squared plus 2a delta x. Now, I'm looking for maximum height, so this is equal to 0. And as we did in the previous problem, this equation works out for delta x to be equal to v0 squared over 2a delta x. Now, this would be the case of what happens for this guy. At v0, it would look like this. For this guy, my delta x would look something like this, and I'll write it in a different color so it stands out. My delta x for him would be 4v0 squared 2a delta x, which works out to be 16v0 squared over 2a just 2a. Let me erase these delta x's there. There we go, get rid of that one. Get rid of that one there, and get rid of that one. Now, if we notice, all of this is the same here as it is here. The only difference is the number 16, which means that this would be 16 times greater.